Welcome to 1.6 Photoelectron Spectroscopy. Alright, for AP Chemistry, this particular section does not have any equations, so we don't have to worry about that, but you will need to have a chem helper or a periodic table of some sort in front of you to be able to identify the elements from the PES graphs. So photoelectron spectroscopy, called PES, is another way to measure relative energies of electrons in atoms and molecules. Okay, so photoelectron spectroscopy is a technique that measures. Okay, it goes from high to low energies, and it uses electromagnetic radiation like UV or X-rays. And it measures the kinetic energy of the electrons. Now, we talked about Coulomb's law briefly, and PES can tie into Coulomb's law, because if we know the kinetic energy of the electrons spinning around the nucleus, we also can tie that into its bond energy. Okay? So PES graphs, they show the relative number of electrons and their binding energy. Right? The PES graphs directly correspond to electron configuration. So it's important for you to understand this is another way to identify an individual element by its binding energy. Okay? Always read the axes. All right? The highest value for the ionization energy or binding energy will be the innermost electrons. That's really important to understand, because there's two different ways you can get a PES graph. Now, the one that is right here, ionization energy, it's in megajoules per mole. And you can see here we've got 1, 10, and 100. So the ionization energy is increasing as you go towards what we would call on a graph the 0, 0 point. So this is reverse on the axes. It doesn't start at 0 and go higher. It starts at a high number and goes lower as you go across. So you really got to pay attention to the axes. So hands down, whether the first thing you should do is each one of these peaks tells you the number of electrons at that binding energy. So we have 2, 2, 6, and then 1. Well, we know that the S group can only hold 2 electrons. The P group can hold up to 6 electrons. The D group can hold 10. And then rarely will you see an F group on a PES graph, but it can hold up to 14 electrons. Okay? So with that, I know this is an S group, this is an S group, and because this is at 1, and it comes right after a 6, which is a P group, this is also an S group. You can also divide it by every S, by period. Now, since this is the highest binding energy, this means these electrons are closest to the nucleus, so this is my 1s2 area. The very next group has to be my second period, 2s2, 2p6, and then here we've got the 3s, and there's only 1. So the electron configuration for this is sodium, and it gave it there to you, and it's 1s, 2s, 2p, 3, 1. Okay, and notice that corresponds to the peaks that is given. Right? And that's really all it is. So if we look at the one below that for the IDO, now this is a different way to see PES graphs. So I'm going to zoom this in a little bit and move this over. So instead of being in a straight line like this and all together, you might see it what's called a stacked PES. Stacked PES graph. All right, and what a stacked is that the higher energy is typically on top, and then the lower energy electrons are on the bottom. So if you look, on the side is the relative amount of electrons, but if you look at down here, we got 10, then it goes to 100, 0, 10, okay? Now this one is reverse of this. We're starting at 0 energy, going to 10, 10 energy, going to 100. That's the other thing you have to recognize. If it's a stacked PES, the range, the part right here is not the lowest. It actually starts at, these kinds start with the highest energy because it's one big long graph. These, because they're separated, they start with the lower energy at the bottom and go across and up to the high energy. Now, hands down, it says which element is represented. So we've got 1, 2, 3 peaks. So we can say it's 2 plus 4 plus 2. Well, 2 plus 4 is 6, plus 2 is 8 electrons total. Well, if I look on my periodic table, that's oxygen. Okay. Now, I'm going to take it a step further. It doesn't ask you to do this, but in other questions it will. What is this first 2? Is that 1s2, or is that my lower energy, and is that my 2s2? Well, we know that oxygen is in the second period, okay? So we know that the configuration for oxygen is 1s2, 2s2, and then 2p4. Okay, so we got to go through hydrogen and helium, that's 1s2, 2s2, and then 2p1, 2, 3, 4. This is the electron configuration, but what is this 2? Is this the 2s2 or the 1s2? Well, let's look at the energies. It's given here, it goes from 10 to 100, it's about halfway, so this has a binding energy of 52.6. This one has a binding energy of 1.31, and this one has a binding energy of 3.014. So if I had to put this in order, this is the lowest, this is the next highest, and this is the highest. So this right here is my 1s2. This is my 2s2, and then this is my 2p4. So it's like you're reading the electron configuration, from right to left instead of left to right. So stacked PES graphs you got to be careful with. Okay. All right. So let's flip this over and look at the redo. So again, you have the video, so you can watch it. This is a stacked PES, but it says which element is represented. Okay. So we've got 0 to 10, and then we got 100 to 500. So this is my high, and this is my low. So we're kind of reading it from right to left, right to left. So I've got 2 up here, then plus 2 again, plus 6, plus 2, plus 1. Okay, so I'm going from right to left, right to left. So 2 plus 2 is 4, plus 6 is 10, that's 12, 13. So element 13 is going to be over here. Magnesium is 12, 13 is aluminum. So just counting up the peaks, I'm getting aluminum with 13 electrons. So that's easy enough. But if it said which one is the 1s group or which one is the 2p group, you would have to be able to identify this. So since this has the highest energy, this one is my 1s2, reading right to left. So coming down here, we got 1s2, then 2s2, then 2p6, then 3s2, and then my final one, and After 2 always comes 6 because we're in P. So don't just assume because it's a little peak it must be an S group. No, this is actually a P group, and this is my 3P1. So 1s2, 2s2, 3p6, or 2p, sorry, 2p6, 3s2, 3p1, in that same order. So be able to identify the subgroups and their electrons from a stacked and a regular PES. All right, let's look at the U-dude problems. So number 1 says which element is represented. Now this one is a single stack. So here the axes, the X, the binding energy, is starting from the highest and going to the lowest. So this has the highest binding energy, so this would be closest to the nucleus. So this is your period 1. And then when the peaks are together like this, we know those go in the same period. So here's period 1, period 2, and period 3. You have to judge, based on where they're at, how many electrons there is, because this is the relevant enough electrons, but there's no numbers. Well, we know S groups can only have 2, so each one of these are 2. A tall group like this, and right after an S group has to be a P group, so this has got to be 6, so you're going to have to estimate this one. Okay. All right, here's another PES. It is not stacked, but look at the axes. We've got the lowest binding energy to the highest binding energy. Typically 99% of the time it'll look like this, but sometimes they will reverse it on you. So you're reading from right to left, highest to lowest binding energy to identify the element, write the electron configuration, predict the charge of this element if it would form as an ion. And I would go through and identify the 1s, the 2s, the 2p, the 3s, the 3p, and so on. All right, number 3, we have a stacked, or we have a PES of oxygen and nitrogen, and identifies it for you. But it's asking you different questions. So here, identify the 2s peaks. So that's why I did a few of those for you. Okay. So for each one, if I would do each one in a different color or label it, do something, to show the difference between your answers of A and B. And then we've got question 4. It says a PES spectra for hydrogen and helium are provided. Which one is which? So label each one, which one you think is hydrogen, which one you think is helium. Explain the difference in intensity, the height, and then the energy. Okay? And then number 5, given the PES for magnesium is shown below, lowest to highest. So you're going to be reading it right to left. Identify the peak that corresponds with the electrons that are lost if this binds. So which one of these groups would be your valence electrons, essentially? Okay? And then why would those electrons be the first to be lost? It's not just that they're valence electrons, tie it into the binding energy. Okay? And that is your 1.6 photoelectron spectroscopy, and I will see you in class.